Welcome back. I hope everyone had a good Christmas break and a happy New Year's. Today we're going to explore properties of exponents. Our first rule that we're going to look at is called the product of powers. When we get x to the m power times x to the n power. Notice both of these powers have the same base. The base of these powers is x. And the exponents are m and n. When you multiply two powers with the same base, you add the exponent. That's what this rule says. So let's look at some examples here. It says simplify the following expression. We got 2 to the second times 2 to the third. So we're going to use this rule, rule 1 here. When you multiply powers that have the same base, so since both of these have base 2, you don't multiply the bases together, so you leave the base as 2. What you do to multiply two powers with the same base is add the exponents. So we're going to take 2 plus 3. 2 plus 3 is 5. So 2 to the second times 2 to the third is 2 to the fifth power. Now, it asks you to simplify it. Since it says to simplify, we're going to do one more step further. What is 2 to the fifth power? That's 2 times 2 times 2 times 2 times 2. So 2 to the fifth power is 32. So 2 to the second times 2 to the third simplifies to 32. All right, let's look at B here. It says simplify the following expression. Well, these two expressions are written beside each other. So that means we're going to use multiplication. So we're going to multiply the powers that have the same base. So I'm going to start with the powers that have base x. So just like we did on the first one, we don't multiply x and the x's together. We just leave the base as x. Just like over here, we just left x as 2. We didn't write it as 4. So what do? I add the exponents. Well, what's the exponent on this first x? I don't see one. So the exponent on that x is a 1. Okay, it's x to the first power. X to the first power is x. So we're going to take 1 plus 5. Now I'm going to multiply my y's together. So I got y to the negative third times y to the 6. Well, let's add the exponents. So let's take negative 3 plus 6. So the answer that we get is x to the 6th power, y to the 3rd power. Now you cannot combine x to the 6th power and y to the 3rd because they don't have the same base. So you can't make this x, y to the 9th power. Okay? Or you can't make it x to the 9th power or y to the 9th power. You can't combine those. You can't use that rule that we just learned. It only works when they have the same base. So this problem is simplified. All right, let's look at another rule. So here's rule 2. It's similar to rule 1. Rule 1 is the product of powers. Rule 2 is the quotient of powers. Notice we're dividing two powers that have the same base. And what it says to do is subtract the exponents. When we multiply, we add. When we divide, we subtract. So let's look at these examples. We got 5 to the 7th power divided by 5 to the 2nd power. So just like on multiplication, you don't do anything with the bases if they're the same. Just keep the bases safe. And what are we going to do? We're going to subtract the exponents. So we're going to the top exponent minus the bottom exponent. 7 minus 2 is 5. So now we got to figure out what 5 to the 5th power is. This is going to be a big number. I'm going to grab a calculator to help me out. So we're going to have 5 times 5 times 5 times 5 times 5. 5 times 5 is 25. 5 times 5 is 25. And then times another 5. I believe 25 times 25 is 625 times 5. So what is that? 3,125. So that's my simplified answer. All right, so let's do B now. Now B is a little different here. We got more we got more than one base here. We got 2 and 4, and we got x, okay? So basically to do b, let's just separate our numbers from our variables. So let's just rewrite this as two fractions. So 2x to the third divided by 4x is the same as 2 fourths times x to the third over x. Well, 2 fourths, we can simplify that. We know how to simplify 2 over 4. That reduces down to just 1/2. And now we can simplify this part. Or dividing two powers that have the same base. What's the exponent of the bottom x? You don't see one, so the exponent is a 1. So this is going to be x to the 3 minus 1 power, which is x squared. So this is 1/2 x squared, or if you want, you can write it as x squared over 2. Okay, rule 3. This is called the negative exponent rule. Basically, when you are simplifying expressions that involve exponents, your final answer cannot have any negative exponents. If it has a negative exponent, it's not simplified. So, if you have a negative exponent, like we do right here, x to the negative a is equal to 1 over x to the a. And if you look over here, we got 1 over x to the negative a, that's equal to x to the a. Basically, what the negative exponent does, it works like an elevator. It moves it up or down in the fraction. It either moves it to the numerator or the denominator of the fraction, depending on where it is originally. So, if we look at this first one, the green one, if you think about x to the negative a, if this was a fraction, that would be over 1. What has the negative exponent? The x does. Where is it located? It's located in the numerator. So what the negative exponent does, it just moves it to the denominator, and then when it moves it to the denominator, it changes that exponent to positive. If you look over here on the blue one, the negative exponent's on the bottom, so it's going to move it to the top, and then when it moves it to the top, it becomes positive, because x to the 8th power is the same as x to the 8th power over 1, which is just x over 8. Alright, so let's look at these examples. So simplify the following expressions. Well, if we look at A, why is A not simplified? Because it has a negative exponent. What has the negative exponent? The x does, not the 2. What's the exponent on the 2? It's a 1. A common mistake that I see people do on this one, they think the negative 3 is on both the x and the 2, but it's really just on the x. Okay, so since it's just on the x, the 2 is going to stay in the numerator, and x to the negative 3 is going to go down to the bottom and become positive. So this is my final answer. Here's what most people would write the answer as, because they believe this is the mistake that a lot of students make. They see 2x to the negative 3, and they write that as 1 over 2 to the x. 1 over 2x to the third. But that's not correct. Like I said, the negative 3 is only on the x, not the 2. That's why we don't move the 2. That's why the 2 stays in the numerator. Okay, let's look at B here. Well, B, I don't see any negative exponents. Okay, but I can use row number 2, the quotient rule. So I can make this x to the 5 minus 7 times y to the 3 minus 2. X to the 5 minus 7 will be x to the negative 2 power times y to the first power. Now we have our negative exponent. Okay? We got x to the negative 2. Remember, we can't have a negative exponent. So what does it do? Well, if this was a fraction, it moves it. So it's going to take the x power and move it down to the bottom. The y is going to stay on top. So this simplifies to just y over x squared. So that's one way to do it. I had to use rule 2 and rule 3 to do that problem. Now, there's a simpler way to do it, okay? I think it cuts down on the mistakes. Here's the way I like to do it. Let's just focus on this problem there. So we got this. X to the fifth. Well, what is x to the fifth? That's x times x times x times x times x, right? And then we got y to the third. That's y times y times y. And then on the bottom, we would have x times x times x times x times x times x times x. We would have 7 x's down there. And then we would have 2 y's. Okay? Well, how many x's can you cancel from the top and bottom? Well, I can cancel this x with that x, this x with that x, this x with that, this with that, this with that. So how many x's are left on the bottom? 2. That's why the x squared is on the bottom over here. Now let's do the y's. How many y's can I cancel out? I can cancel this y with this y, and then this y with that y. But this y here doesn't have a, this y right here doesn't have a y down here to cancel with it. So there's a y left over on top of it. That's another way to do it. You don't have to write it out every time. You can just think of it like this. You got x to the fifth, you got x to the seventh. So how many x's can you take away from both the top and the bottom? 5 of them. So you can mark out all of these on top, and then mark out the 7 and replace it with 2. How many y's can you take away from both the top and bottom? 2 of them. So they're completely gone on the bottom. You have 3 on top. You took 2 away, now you're left with 1. So it's y over x to the 7. Alright, so this is going to be our last property that we're going to look at today. It's actually one of the easier ones. It says, if you take some base and raise it to the 0 power, as long as that base is not 0, then that answer is 1. So x to the 0 power is 1. So if we look at A, we get 7 to the 0 power. Well, anything to the 0 power is 1. So the answer is just 1. Okay? Now, let's look at B. A mistake that students make on B is they say the answer is 1. But the answer is not actually 1. Because the whole thing is not to the 0 power. Only the variable y is to the 0 power. Okay? So only the y is to the 0 power. So what is y to the 0? 1. And then 2x to the third is just 2x to the third. So we got 2x to the third times 1. 2x to the third times 1 is just 2x to the third. So now it's simplified. But if I would have had B, B would have been written like this. 2x to the third y, the quantity, raised to the 0 power. That would be 1. Because this whole expression here is raised to the 0 power. And anything to the 0 power, no matter how complicated it looks, is just 1. Alright, before we finish this lesson, I just want to review some other stuff that ties in with today's lesson. Okay, we're going to be also simplifying expressions like this. So let's look at these 3 examples. A, we're multiplying 2 expressions here. So we're going to be using the rules that we learned today. Okay, so we want to multiply these. So you start with your coefficients. 2 times -7 is -14. Now let's multiply our powers that have the same base. So let's take x times x to the 4th. Well, what's the exponent on the x? For 1. What do you do when you multiply 2 powers with the same base? You add the exponent. So this will be x to the 5th, because 1 plus 4 is 5. And then do a y's. So I got y to the 5th times y to the 7th. So that's going to be 5 plus -7, which is -2. So there's my answer. Now I just gotta make sure I don't have anything that makes it not simplified. Well, the negative exponent on the y makes it not simplified. You're not allowed to leave a negative exponent. The negative on the 14 is fine. The coefficients can be negative. The things that can't be negative are the exponents. So the 14 won't move. The x to the 5th won't move. Remember, you just imagine if this was a fraction. So if this was over 1, okay? What has the negative exponent? The y does. So the y is going to be relocated down to the bottom part of my fraction. So the negative 14, x to the 5th, will stay on top. And when I move the y down to the bottom, I make the exponent from negative to positive. That's the negative exponent. There's my simplified answer. Okay, let's look at B. What are we doing here? We're subtracting two trinomials. Okay? We did stuff like this in the last chapter. Okay? In order to subtract or add like terms, they have to have the same variable to the same power. So what I would do first is I always like to rewrite subtraction into addition. So I'm going to change this minus sign into a plus sign. Well, what I'm going to need to do now is change the sign of everything that follows that subtraction sign. So this 4 becomes negative, the 5 will become positive, and the 10 will become negative. Now I'm going to add my like terms. And again, like terms have the same variable to the same power. So I got 2x squared and negative 4x squared. They both have the variable x to the second power. So I can add these together. So I just take 2 plus negative 4, which is negative 2. And when you add powers together, you don't do anything with the exponents. So the exponents just stay the same. The only time you do stuff with the exponents is when you multiply and divide. Okay? So now, let's take positive 3x plus positive 5x, which will be 8x. And then last, negative 5 plus negative 10 would be negative 15. So there's my simplified answer. I can't add these terms together. I can't add the negative 2 and the 8 together because they're not like terms. Because the 2 contains x squared, the 8 contains just x. So it's simplified. All right, now let's look at C. Well, C looks like a problem you've seen before. For problems like this, we always do FOIL. So we're going to take the first term times the first term. So I'm going to take 3x squared times x squared. So I'll multiply the numbers in front. So 3 times 1 is 3. Now I'm multiplying two powers that have the same base. What do? We add the exponents. So 2 plus 2 will be 4. So 3x squared times x squared gives you 3x to the 4th. Now let's take 3x squared times negative 7. That's going to give me negative 21x squared. Now let's take negative 5x times x squared. That will give you negative 5x to the 3rd. This is x to the 1st times x to the 2nd, which is x to the 3rd. And then negative 5x times negative 7 is going to be positive 35. Okay. Usually when they ask you to simplify an expression, they always want you to write the powers in decreasing order. Okay. So my biggest power is to the 4th power, so I'm just going to leave that at the top. My next biggest power is to the 3rd power, so I'm going to write that second. And then I got to the 2nd power. And then I got my 35. Do I have any like terms? Can I combine any of these numbers together? No. So this is simplified. This is my final answer. So tomorrow, we're going to look at some more rules of exponents. But today, you're just going to be practicing these 4 that we went over.